In this section, we're going to talk about higher order derivatives. So higher order derivatives are when you do derivatives of derivatives. So the notation for that, I should have had a box about this, but notation for the second derivative or any higher order derivative, okay, you can put, so you have y equals f of x here. So you can just, so the second derivative, for example, okay, you could write f double prime of x. So you can write these two little marks here. But the other way that you can write it is you can write, you write it like this. So this is also the second derivative. Okay, this is indicating, this number 2 here is indicating the second derivative. So on the top, you put the 2 next to the d, and on the bottom, you put the 2 next to the x as an exponent. That's just the way that it is. You just have to accept it. If you want to do the nth derivative, okay, you can keep adding these primes here, but people don't generally add primes past 3. Like the most you would see probably is with a 3 here. You wouldn't see 4. So if you want to do higher order derivatives, what you can do is you put an n in parentheses like this. Okay, that would be the nth derivative, and then similarly you would write the nth power on the d here, and then the nth power on the x down here. Okay. You want to be careful though, because it's not like this. Okay. This means the nth power. Okay, it doesn't mean the nth derivative. Okay, so that's the nth power of the function, not the nth derivative. Okay, so basically, if I wanted to use my other notation for this, this is the same thing as saying the second derivative of x over x squared plus 1. So if I wanted to use that notation, that's what it would say. Okay, so if you want to find a higher order derivative, I mean, obviously you have to find the derivative before it. So if I want to know the second derivative, I better figure out what the first derivative is first. So here I'm going to do the first derivative and then use it to find the second derivative. So here we have to do the quotient rule. So it's the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, okay, which is 2x. So let's make sure we know why. So the derivative of the bottom, okay, it's the derivative of x squared, which is 2x. And then the derivative of 1 is 0. So that's why I don't have any number here. Divided by the bottom squared, which is x plus 1 squared. Okay, so let's simplify this a little bit. Generally, you don't want to multiply out the denominator. That's just going to make your life a lot harder. But in this case, we kind of have to, because we need to take the derivative again, so we need to square this out in order to do that. We don't have a rule for a function squared, so we're going to have to multiply this out in order to do this derivative. So this is going to be, notice, well, I'll just write it out. This is x squared plus 1 minus 2x squared, okay, divided by x to the 4th plus 2x squared plus 1, okay, multiplying it out. So finally, my first derivative here, my first derivative is going to be, so see, x squared minus 2x squared, that's going to be negative x squared. So it's 1 minus x squared over x to the 4th plus 2x plus 1. Okay, so that's my first derivative. And now I want to do the second derivative. Okay, so we're going to do The second derivative is the derivative of the derivative. So I have to take this function now and do the derivative of that. So it's going to be the bottom, quotient rule again, bottom times the derivative of the top, which is negative 2x. So again, derivative of 1 is 0. Derivative of x squared is 2x, but I have a minus here, so that's where that comes from. So the bottom times the derivative of the top minus the top times the derivative of the bottom, which is 4x cubed plus 4x. Okay, so again, the derivative of x to the fourth is 4x cubed. The derivative of 2x squared is you keep the 2 and multiply by the derivative of x squared. So that's where the 4 comes from. And the derivative of 1 by itself is 0. And then I have this all over x to the fourth plus 2x squared plus 1 and then squared. Okay, so you just want to simplify this now. A lot of algebra going on. So this is going to be negative 2x to the fifth minus 4x cubed minus 2x minus, you have to multiply this out. So this is 4x cubed minus 4x minus 4x to the fifth minus 4x cubed. Okay, so let's discuss this real fast. You have to FOIL this. So these first two terms are from doing 1 times 4x cubed plus 1 times 4x. So this should be a plus. And then the second two terms here are from doing negative x squared times 4x cubed, okay, which is negative 4x to the fifth, and then negative x squared times 4x, which is negative 4x cubed. So when I first did this, I had a minus here, but that wasn't right. So it's a good thing that I'm checking, because otherwise I'd be getting the wrong answer. And then I have this all over x to the fourth plus 2x squared plus 1 squared. Okay? So now you just want to simplify this. So now we have negative 2x to the fifth minus 4x cubed minus 2x minus 4x cubed minus 4x plus 4x to the fifth plus 4x cubed. So now we can combine all of our like terms. X to the fourth plus 2x squared plus 1 squared. So we have negative 2x to the fifth plus 4x to the fifth. So this is 2x to the fifth. We have negative 4x cubed minus 4x cubed plus 4x cubed. So this is minus 4x cubed. And then I have negative 2x minus 4x, which is negative 6x, all divided by x to the fourth plus 2x plus 1 squared. Now you want to try to factor and simplify. So this is going to be 2x times x to the fourth minus 2x squared minus 3. So we're factoring out a 2 and an x. Okay, and we still have our denominator, x to the fourth plus 2x plus 1. So here we have to factor. Okay. So we're going to have x squared and x squared here. We're going to have a 3 and a 1. And then you just have to figure out the signs of these here in the middle. Okay. And I have a -2, so that should be a -3 plus a 1. Okay, so we have -3 plus 1, and we still have our denominator. But if you remember, x to the 4th plus 2x plus 1, we can factor that. So really, this is x squared plus 1 squared, and then squared again. So this is the same thing as 2x times x squared minus 3 times x squared plus 1 divided by x squared plus 1 to the 4th. And then I can cancel one of these and I'll get a cube. So this is our second derivative, 2x times x squared minus 3 divided by x squared plus 1 cubed. Okay, so this is our second derivative for that function. So this is a really big pain. Won't have you do these ones too much, but just so you see, these problems can kind of take a while. So you want to make sure you leave enough time to be able to figure them out when you're doing your homework and stuff. So that is the second derivative of the function x over x squared plus 1. And then if you had a product, you would have to do the product rule. If it was just one of your basic rules, then you would just use your basic rules. But the point is that you do the derivative of the derivative in order to figure out the second derivative. So say you had an application problem though. So say you have a function that's giving you the height in meters after t minutes. We want to ask ourselves, what is meant by the second derivative? So what does that mean? So let's just remind ourselves, when you do the first derivative, okay, and we can do that for this. So 300 minus 12t squared. You might want to pause and think about why this is right. Remember the units of this, so remember the position, you have input is seconds and output is meters. The units of this are going to be meters per second. So the first derivative is the velocity in this case. So let's think about the second derivative. So the second derivative is the derivative of the derivative. Okay, so the units of the second derivative, okay, so just relate that back to what we talked about with regular derivatives. So this would be the units of the function we're taking the derivative of, which is s prime this time, not s. So the units of s prime over the units of t. Okay, so this would be meters per second and then seconds again, which is meters per second squared. Okay, and we all know this as acceleration. So when I do the second derivative, I'm going to get -24t. The units of this are meters per second squared. So this is going to be the acceleration. Of the object. So in terms of the units of derivatives, you just keep on adding. So every time you take a derivative, you would get another power of the input on the bottom. So imagine you took the derivative again, just for fun. So imagine you did the third derivative, okay? This would be -24, but then what would the units be? It would be meters per second squared per second, which is meters per seconds cubed. And if anybody's a physics person, this is jerk. I don't know what it means, but that's what it's called. But the point is that every time you take a derivative, you get in your units just another power of the input variable. So we start out with just meters. The first derivative would be meters per, oh, it says minutes. Dang it. I'm just going to erase this and put seconds. So it would be meters per second for the first derivative, meters per second squared for the second derivative, and then meters per second cubed for the third derivative, meters per seconds to the fourth for the fourth derivative, etc. So that's how the units of higher order derivatives work.